Hello, my name is Karan Mehta. I am from DJ Sangvi College of Engineering from Department of Electronics. Today's subject for practical is Design with Linear Integrated Circuit. The course code for the subject is DELXL504. The simulation software which we used is eSim. The name of the experiment is Design of an Inverting and Non Inverting Amplifier. The professor in charge for our practical is Mayur Parulekar sir. The software download link is this, and the tutorial for the same software is available on spokentutorial.org. Now let's move to the theory of inverting and non-inverting amplifier. So this is the diagram for inverting amplifier. As the input is provided to inverting terminal of an op-amp, the output is 180 degree outphase with the input. The gain for this op-amp is minus RF upon RI. This is the diagram for non-inverting amplifier. As the input is provided to non-inverting terminal of op-amp, the output is in phase with the input. The gain for this op-amp is 1 plus RF upon R2. Now let's move to the simulation part of this practical. First, download the eSim software from the given link, then install it. This is the shortcut key for eSim software. Double click to run the software. After this, you will get this terminal. Press cancel to continue. This is the main page of eSim window. To create a new project, click on this icon. Enter the project name. The project is added in the Projects tab. Select the project by double clicking on the project name. Now let's create the schematic window of the project. To create a schematic window, there is an option for schematic window. Click on that. This window says that there is no schematic file present for the project, so do you wish to create it? Press yes to continue. The new blank schematic window is created. Now let's draw the schematic for the given practical. For pressing a new component, press key A from your keyboard. Search for component LM_741. Select your component and press OK. Again, for adding extra component, press A keyboard shortcut. Search for eSim_R to place resistor. You can scroll in and scroll out to zoom. Put your cursor on a component and press C to copy the component. Select a component and press R to rotate the component. To join the component using wire, place your cursor on the terminal of a component and press keyboard key W. Now to give the input, we need a sinusoidal wave. To do so, again press A. Search for eSim_sources. Search for sine component. Press OK to select the component. Press the component in the schematic. To move the component, place your cursor on the component and press key M. Now the op-amp requires a dual power supply. To do so, search for DC power supply under eSim_sources. short the terminal negative and positive of first and second battery respectively. Now to place a ground component, press key P. Under eSim underscore power, select ground component. Place the component. Now join the positive of this battery to terminal 7 of an op-amp and negative of the second battery to give minus VCC to terminal 4. Now let's change the value of resistors and battery. To do so, place your cursor on the component and press key V. Change its value to 1 kilo ohm. Similarly, change the value of feedback resistor to 1 kilo ohm. This combination we are doing is for gain of 2. The formula for non-inverting is 1 plus Rf upon Ri. So 1 plus 1 upon 1, that is 2. Change the value of battery to 15 volts. Now let's place the label at output and input terminal. To do so, select place global label and put the value input for the input node. Similarly, do so for output node. We need to plot the graphs for input and output node. To do so, press key A and search for eSim underscore plot. Select plot V1 component. Press OK. Copy the same component to place at the output side. Now let's annotate our schematic. To do so, press on this key and press annotate. Press OK. Now our schematic is ready. Now let's generate the .cir file, which is the netlist of this schematic. To do so, press on this key. Select Spice tab, select the default format option and click generate. Save the file. The .netlist file is generated. Now let's move back to the main terminal of eSim. Now press KiCad to ngSpice key. Enter the source detail and select the transient analysis. Enter start time as 0, step time as 10 microseconds and stop time as 10 milliseconds to get the smooth curve. Go to source details tab, enter offset value as 0, enter value 1 for 2 volt peak to peak input, enter frequency as 1000 Hz, enter delay time as 0 and damping factor as 0. Now go to sub-circuits tab. Now select add. Search for LM741. Select the folder. Now press convert key. The following message shows that the KiCad to ngSpice conversion completed successfully. Press OK. Now press the simulation key. Enter the command plot space output comma input, which are the label for our graph. The following is the graph for our simulation. As you can see here, the input is the waveform of red color, which is from 2 volt peak to peak, and the gain for the system is 2, so the output is 4 volt peak to peak. This combination was for gain 2 and input 2. After doing the multiple combinations for the same, you will get different values of gain and different values of output. This is the observation table for gain 2. This is the circuit for non-inverting amplifier and this is the circuit for inverting amplifier. The procedure to draw the circuit for inverting amplifier is same as non-inverting amplifier. Change the value of R1 and RF accordingly to get the gain. After that, change the value of input voltage from 1 to 5 to get the different output. The following plot is for inverting output for V in is equals to 2 volt peak to peak. This is the inverting amplifier for gain is equals to 3 and this is the non-inverting amplifier for gain is equals to 3. Note that if you select input voltage such that your output voltage crosses the saturation voltage, your waveform will get clipped. In my case, for gain is equals to 5, I have chosen the input voltage as 8 volt peak to peak, so ideally it should give output as 40 volt peak to peak, but my output voltage stops at 13.7 volt and minus 12.8 volts. As it is seen in this waveform that the voltage gets clips at V saturation. So from this, we conclude that the output goes into saturation at plus 13.7 volt and minus 12.8 volt. So this was simulation of non-inverting and inverting amplifier in eSim software. Thank you.